For this circuit, I need to find the power dissipated by the 2 ohms resistor, and I need to use mesh current method for this one. So what I see, I can see there are 3 meshes here, and there is a current source which is this one. So let's assign the mesh currents first. I will assign them counterclockwise as I have done before, but they can be clockwise, but they could be done counterclockwise as well, but I have done clockwise in the previous ones as well. So I1, I2, I3. Now what I notice here is I3, since this is a current source here, I3 will become minus 16 amps. So that is just the value of I3. So I3 is known already. We will write mesh equation for the first 2 meshes, I1 and I2. So basically KVL for the first one. So if I start from here and go clockwise, in clockwise direction, 30 volts is a rise. So let's write it on the left hand side, and then on the right hand side maybe the drops. So as I can see, there are 3 resistances in this loop, 3 ohms, 2 ohms and 6 ohms. So if I add them up, it will be 11 ohms. So 11 I1, I'm just writing it directly. Then the common resistance between loop 1 and loop 2 is 2. So that one I can write minus 2 I2. So it should be minus 2 I2. And that's it. There is no more resistance. So this is one equation here. Let's call it equation 1 there. And then for the second one, there is no source here, so that's 0 here. And there are 4 resistances here, 4 ohms, 2 ohms, 8 ohms and 5 ohms. So if I add them up, 4 plus 2 plus 8 plus 5, that will be 19. So here we will have minus 19 I2, and the common resistance between 1 and 2 is 2 ohms, so that will be minus 2 I1. 19 I2 will be plus, sorry, that will be plus here because that's the loop, the current of the loop current basically of that particular mesh, that's the current. Finally this one, the common resistance is here is 5, so that will be minus 5 I3. So that one we can write 0 here, minus 2 I1 plus 19 I2, and this one is minus 5 into I3. I3 is minus 16. So minus 5 minus 16 is becoming plus 80. So the equation becomes like this, minus 80 2I1 plus 19I2, like that. So that is equation 2 here. So we need to we have 2 equations. So what I will do, I will multiply 1 times 2 and then add 2 plus 2 multiplied by 11. So I'm just trying to get rid of the 1's there. So when 1 multiplied by 2, it will be 60 here, 22 I1 minus 4 I2 because that was 2 here, and when equation 2 multiplied by 11, that will become minus 880, and here minus 22 I1, and this one will become 19 times 11 is 209 I2. So I will add these two, and what I will get is minus 820 because minus 880 plus 60, and here I will have 205 I2. So my I2 will become minus 820 over 205, which is minus 4 amps. So that is I2. So I already have I2. Now I need to get I1. So I can use one of the equations. Let's do the first one. So 30, 11 I1 minus 2 I2. So that's become 30 here. 11I1 minus 2 times minus 4, so that will become 8 here. So 30, 11I1 and plus 8 here, so 11I1 is equal to 30 minus 8, which is 22, so I1 is equal to 2 amps. So we have both I1 and I2. Now we needed to find the power of, that's what we need to find, the power dissipated by the 2 ohms resistance. So that will be, of course, I square R. So what is the current across the 2 ohms resistance? The direction doesn't matter, but we can actually we know the direction now, because I1 is positive here and I2 is in this direction, but it's actually negative, so it will be in the other direction. So basically the current here I would be I1 minus by I mean the current, let's say I2, 2 ohms, so that will be I1 minus I2. Basically that's the current. Now I2 is, I1 is 2, I2 is minus 4, so it's becoming 6 in the downward direction. That's the current. The direction is downwards and the value is 6 amps. So I square R will be 6 square times 2, so that will be 36 times 2, that is 72 watts. So that's the power dissipated by the resistance.